The division property of equality states that if you divide both sides of an equation by the same thing, you still have the same equation. In other words, you produce an equivalent equation. Now your book example was like 3 times x is 12, but 5 times a number is 20. Would you agree? That's a possibility? Yeah. And since you all know your math facts, you're probably going to tell me that x is 4, right? X is 4, Mrs. Myers, because 5 times 4 is 20. Remember, when you have a variable next to a number, it means multiply. When you have a variable next to a number, it means multiply. So 5 multiplied by x is 20, but I don't know what x is. So to undo the multiplication, I divide. Divide each side by 5, and now I have 1x. Remember, we don't really write the 1 when it's the coefficient, but in any case, I now know that 1x is equivalent to 4. Agree? All right. We can look at a few examples of this real quick. Here's a couple. What do you need, Rach? Oh, okay. 12w equals negative 96. What is 12 being multiplied by to produce a negative 96? If you don't know, which I'm not sure how many of us have our 12s memorized, divide by 12. And after you've thrown your calculator on the floor, you can discover that negative 96, clear, negative 96 divided by 12, let's see what that gives us. Okay, something not right. You'll discover that 96 divided by 12 is going to be, wow, thing's doing something really weird. Maybe I dropped it one too many times. Is going to be a negative 8. What if you put a positive 8 there? It's wrong, because 12 times positive 8 is a positive 96. Be careful with those. The same function works even if you have it written negative 60, say, equals something times a. Notice that the variable is on the left over here. The variable's on the right over there. That does not change how we process this. It doesn't make a lick of a difference. Sarah, I'm still not used to you being over there. Divide everything by a negative 5, which produces 1a being equal to the result of this division. And if you put it in, you'll find it's a positive 12. What if you said it was a negative 12? That would be wrong, because negative 5 times a negative 12 would produce a positive 60. Okay, there's just a couple of examples for you. So that is how that works with a multiplication problem. We undo multiplication by using division. Example 2 is where we encounter the multiplication property of equality, which says the same thing as the rule above, except it says if you multiply both sides by the same thing, you produce an equivalent equation. Okay, you've already copied that. So the multiplication property of equality states that if you multiply both sides by the same thing, you produce an equivalent equation. What this is telling me here is that W is equivalent to negative 8. Why? Because it's telling me 12 times this thing is that. So some example 2s for you. I've got a couple of them, and you have to practice these. First one I want to do. Some number cut in half is equal to 13. Some number cut in half is equal to 13. Any of you already know the answer without doing anything? Emma? 26, she's right. But in case you didn't recognize that, we're gonna multiply to undo the division. And you multiply by the divisor. By the divisor, which in this case is a 2. If I multiply this side by 2 and I multiply that side by 2, I want you to recognize something here for a second. You guys learned about multiplying, and when you multiply a whole number, 2, by a fraction, you would draw an imaginary 1 underneath it just for your own sanity. Sometimes you don't. I don't care, whatever works for you. But the end result here on the left is y. Why? Because I love you. 13 times 2 is 26. Emma said it was 26 and she's right. You're gonna want to practice this. This is A. A said y divided by 2 is 13. So we multiplied to undo the divided by 2. Instead of dividing by 2, we multiplied both sides by 2. That canceled out what we were dividing, left us with y equaling 26. If you plug it in here, 26 cut in half indeed will give us 13. Don't let numbers that are big or numbers that look weird scare you, like this one I'm about to share with you. Still do the same stuff. Some number divided by 8 equals -8. By the way, I can also write it -8 equals b divided by 8. That doesn't change how I'm going to solve this. Some number cut into 8 equal groups gives me -8 in each equal group. Izza, what do you think the answer is? For the one I just put up there. Yeah, and if you didn't know that, you can multiply both sides by 8. Well, I can do that here too. That cancels out the divisor, just like it does over here. Whichever way you answer it, it's fine. B is -64, -64 is B. It's almost like speaking in reverse. He is Ben, Ben is he. I mean, you know, whatever. Okay, same idea. B for Ben, sorry. Okay. The next thing I want to share with you is example 3. And here it is. You can look, we'll look at the book example here in a minute. But I'm going to give you my example. Lee biked an average speed, wow, of 4 miles per hour. That's slow. I don't know how he could possibly bike that slow without tipping over. That's like walking. Okay. To get to the post office, which was 1 mile away. How long did it take her to get there? This one is a little bit trickier than it kind of seems. Eli, he's right, but how did you figure it out? I know, right? Yeah. Figured it out. Okay, so you know what we just learned? 4 miles per hour, which is the rate, multiplied by how long, which is the time that they're asking, gives us the distance, which is 1 mile. Bear with me, bear with me. Rachel's about to throw a tomato at me, it's okay. Rate times time equals distance. Like I'm going to Susie's house. I drive 25 miles an hour. She lives 100 miles away. How long will it take me? 4 hours, right? Well, to solve for this, we divide, and again, just bear with me. You all did this in your head. X is equivalent to 1/4 of an hour, right? Because it's miles per hour. 1/4 of an hour is how many minutes? 15 minutes. Okay? So even though you took this and divided it up in your head, bigger numbers, you would be able to use this same scenario. As in the book's example 3. You guys want to look at it with me? In 03, the Soho spacecraft, described on page 97, which there's a neat picture of it. It's a sun-studying spacecraft. Solar and Heliospheric Observatory. Anyways, this particular craft could detect solar wind traveling at 2 million, kilometers per hour. That's how fast the solar wind travels. Boy, that thing can really fly. Whew. The sun is 150 million kilometers away. So this is the rate it's traveling. The distance the sun is to us is 150 million kilometers. Distance. How long did it take? Sounds like time to me. Time. So if rate multiplied by time is equal to distance, and I know the rate, wow, it's a lot of zeros, but I don't know the time, and there's the distance, I can take all that and solve. Divide by 2 million, and this is in your book in case you can't see mine real well. Yes, ma'am. Example 3 at the bottom of page 98. So if I take the calculator that I just stole from Zoe, 150 million divided by 2 million kilometers. 1, 2, 3, 4, 5, 6. I end up with 75. Time tells me 75. Now, since it's kilometers per hour, it sounds to me like it takes 75 hours for solar winds to reach us, which is kind of interesting, actually. The people that talk about our atmosphere and the northern lights and different things, they will tell us when the solar winds, which is radiation coming from the sun, they'll tell us when those solar winds are strong, and maybe we'll mess with our satellites, or maybe we'll make the solar or the aurora borealis extremely interesting. And the reason they're able to predict that is because they have 75 hours from when it's ejected to the sun, from the sun to get here. They're able to predict that. Whereas light takes about between 4 and 10 minutes. I can't remember. It's like a real small number to get here. So if the sun quit shining right now, in 5 minutes it'd be black. Anyways,